Bismillahir Rahmanir Rahim. Assalamu alaikum students. This is Hamza Noor, and in this particular video I'm going to solve the question number 2 of International A-Level Edexcel P4 January 2022 paper. So here the requirement of part A is to find in ascending powers of x the first three non-zero terms of the binomial series expansion of cube root of 1 plus 4x cube, where absolute value of x is less than 1 over cube root of 4, giving each coefficient as a simplified fraction. So in part A, we need to expand 1 plus 4x cube whole thing raised to the power 1 over 3, and we need to find the first three terms only. And as you can see that the first term is already 1, so you don't need to factorize it before expanding. So the expansion will be 1 raised to the power 1 over 3 plus NC1. So in place of NC1, we can substitute N. So 1 over 3 multiplied by 4x cube. Okay. And then we have the term which is related with NC2. So NC2 means N into N minus 1 over 2 factorial. So 1 over 3 multiplied by minus 2 over 3 divided by 2 factorial multiply by 4x cube whole squared. Okay, and in this way we will get the first three terms. We don't need to go beyond this because this series will go up to infinite terms. All right, since the power of the binomial expansion is basically a fraction. So hopefully you have covered all the concepts of this particular chapter, binomial expansion, in detail. So first term is basically 1, and then we have 4 over 3 into x cube. And then in your calculator, you will evaluate 1 over 3 multiplied by minus 2 over 3 divided by 2 factorial. It will give you minus 1 over 9 and then multiply by 4 square. So this is minus 16 over 9 multiply by x raised to the power 6 because x cube is also squared. And here we have the first three terms. Therefore, the answer is 1 plus 4 over 3 into x cube minus 16 over 9 into x raised to the power 6. This is supposed to be the answer to part A. All right, so now let's move on to part B. It says that use the expansion from part A with x is equals to 1 over 3 to find a rational approximation to cube root of 31. So the rational approximation means that you need to give your answer as a fraction. So here we need to substitute x is equals to 1 over 3 into cube root of 1 plus 4x cube. Okay, in place of x, I'm going to write 1 over 3. So first of all, I'm going to see what do we get the exact fraction over here. So we get cube root of 31 over 27. So we need to find an approximation for the value of cube root of 31. So now I can say that cube root of 1 plus 4 times 1 over 3 cube. This is equals to cube root of 31 divided by cube root of 27. All right. So if I make cube root of 31 the subject of the equation, this will be equals to cube root of 27 multiply by cube root of 1 plus 4 times 1 over 3 cubed. And since the cube root of 27 is basically 3, so in order to get the value of cube root of 31, 3 will be multiplied by the expansion of cube root of 1 plus 4 times 1 over 3 cubed. But we need to find the rational approximation. We need to find an approximated value. So what we are going to do, we are going to use the expansion which we obtained in part A by expanding the cube root of 1 plus 4x cube. Okay, and the only difference would be over here is that 3 will be multiplied in the end. So this means that if you want to find an approximated value of cube root of 31, this will be 3 multiplied by, in part A, we found the expansion 1 plus 4 over 3 into x cube minus 16 over 9 into x raised to the power 6. So in place of x, we are going to substitute 1 over 3. So the approximated value for cube root of 31 is 3 is completely multiplied by 1 plus 4 over 3 times 1 over 3 cubed minus 16 over 9 times 1 over 3 raised to the power 6. Okay, so 1 plus 4 over 3 times 1 over 3 cubed minus 16 over 9 times 1 over 3 raised to the power 6. So here we get a fraction 6869 over 6561. So 3 is multiplied by 6869 over 6561, and this is supposed to be 6869 divided by 2187. This is the rational approximation of cube root of 31. All right. So this is supposed to be our answer to part B. So this was question number 2 of International A-Level Edexcel P4 January 2022 paper.